All right, part 2 of the phase diagram worksheet. We're just going to go over the answers and kind of look at it. So the part 1 actually went through number 11, so we're going to start with number 12. And number 12 states, or asks the question, if a quantity of the substance was at an initial pressure of 1.5 atmospheres and a temperature of 300. So that's initial, that means it's beginning. So ATM is at 1.25 and the temperature is 300. So 1.25 and 300. So that's initial is right here, okay, initial temperature. Then it says was lowered to a pressure of 0.25 atm. So the temperature is going to stay the same. It's just lowering that pressure. This is what phase transition would occur. You can already see that answer. It's vaporization. But let's look at why it's vaporization. So if I'm here and I'm going down to 0.25, I'm just going to slide this dot down to 0.25. It's going from a liquid to a gas. And that phase change from a liquid to a gas would be vaporization. So that's how we get vaporization. Same thing with number 13. You're doing the same thing, and you are changing to a lower pressure, 0.25, but this time you're having 0 degrees Celsius. So you locate this on your graph, and then you lower to a pressure. And what happens here is it would be sublimation, because this would begin as a solid and would go, once you drop the pressure, would go down to a gas. So again, 1.25 at 0 degrees Celsius is a solid. And if I drop that down, it drops from a solid directly to a gas without any change in temperature. So if you can change the pressure, you can change the phase without changing the temperature, which is a strange concept to think about, but it is. It happens. So let's look at these. These are kind of if and then questions, same thing, like these were. Number 14 is freezing. Number 15 is deposition. Number 16 is 100 and about 175. That's kind of, not to say questionable, 175 degrees Celsius. If you were around there, if you said 180, you know, even 185, something like that is fine. 170 is fine, degrees Celsius. Number 17, this says if a substance was at 2 atmospheres, at what temperature would it boil? And if you notice over here at 2 atmospheres, if you go over here, this is going to fit into that critical, past that supercritical fluid. So it's indistinguishable, so it's never going to boil at this one because it's indistinguishable. So the answer there is never, okay? And we don't have a lot of those, but that was just on the sheet. Let's look at this. If a substance was pressurized at 0.75, at what temperature would it melt? So you find that 0.75 on the graph and you follow it along to see its melting point, and that would be 90 degrees Celsius. Number 19, at 0.75 atm's temperature would it boil? That would be about 150 degrees Celsius. Number 20, at what temperature do the gas and liquid phase become indistinguishable of each other? And that's that critical point. And so we're looking for the temperature for that one, which is 820 degrees Celsius, which is here, because that's the critical point, and that happens just past 800. Okay, 820 degrees would be a good estimate there. At what pressure would it be possible to find this substance in a gas, liquid, and solid phase? At what pressure would it be possible to find this substance in a gas, liquid, and solid phase? So it's asking for the pressure. So remember, we're looking for that triple point, and you're going to follow that over, and you're going to look at that pressure. So I said 0.7 because it's just under 0.75. If you said 0.65 or something like that, that would be fine too, looking at that triple point for number 21. Number 22, if I had a quantity of a substance at a pressure of 1 atmosphere and a temperature of -100, what phase changes would occur if I increase the temperature to 600 degrees Celsius? At what temperatures would they occur? So if you look at 1 atmosphere at -100, which is here, okay, and you are going to increase that temperature to 600, you basically want to know the phase changes between this point and this point here. So as I move along, you can see this solid is going to begin to melt, or it's going to melt at 100, and it's going to come on along. When it hits this line and intersects, that's just past 300, maybe 330 degrees, it's going to vaporize into the gas, right? So That's what I put here. I think I put 350. It probably should be closer to 330 degrees here. So it melts at 100 degrees Celsius, boils at, I like 330 degrees, a little bit better than 350. All right, and then if you had a quantity, same thing. What's happening here? 2 atmospheres of pressure, a temperature of negative 150. What phase changes would occur if you decrease the pressure to 0.25 atmospheres? So what pressure would they occur? So what we're looking at is 2 and negative 150, which is here. Negative 150 and 2 is here. So if I were to reduce that to 0.25, I think it says 0.25 ATMs, this thing would sublimate at 0.25 ATMs. All right, so you notice that that is the point right there where it sublimates. So that's what would happen, sublimation at 0.25 atmospheres.